Hello everyone, welcome back to GeoMicros. In today's video I'm going to show you how you can generate time series graph using Moody's data for NDVI. So you can generate a graph showing how NDVI has changed from year to year. So we are going to use a particular year, that's from 2000 to 2023, to show you a graph of how the land use land cover has changed using a Google Earth engine. So the first thing we need to do is we need to generate our code or type our code, and then as you can see I already have my code here, and then as you can see this is my study area. I'm using a savanna region, and then you can see, and then if you don't know how to import your study area, you can check my video. I have a you can check my page. I have a video on how to import a shapefile into ArcGIS Pro, and then you can see I have a lot of shapefiles here. So if I want any of them, I'll just click on it, and then if it is open, I'll just click on import here so that I can get it on the screen or on the code editor. So I can just click on import and then get it. So the next thing we are going to do is after getting your shapefile, you have to select your that's the region of interest, ROI, that's your savanna region. So if you add your study area, to automatically add your ROI here, and then the next thing is we are going to load our Moody's data. So how I'm going to teach you how you can load your Moody's data. So you can see we have a search bar here where you can type the Moody's data, but you have to know the Moody's data that you are going to use. We have a code for any Moody's data for NDVI, land use land cover, or land surface temperature, and then others. So you can just search for your Moody's data here. As you can see, I have already typed my Moody's data, so this is the data we are using. So we have Moody's 13Q1, that is Terra vegetation. This is a 16-day global which has a 250 meter, and then we are also using this one here. So let me just show you. Okay, so we are using Moody's 006 here, that's the ocean reflectance daily global 1 kilometer. So let me show you. Alright, so we are using Moody's 006, and then we are using Moody's 13Q. As you can see, I have successfully loaded here, and then this is the filter. So you have to filter the year. So this one I'm using 2000 to 2023, which if I want to change this one, I can change it to any date of my choice. And then this is the apply scale factor, that's the NDVI store info at 0.001, that's the scale factor. And then we have our chart here, that's the create NDVI time series charts. This is our chart, and then we have our set by option, that's the NDVI time series 2020. So you have to specify the dates here too, so that the year, so that we can get our, and this is the our add mean NDVI layer to the map. So this particular script here is telling you how we are going to add our NDVI to our map, and then we have our mean NDVI. So we are calculating for our mean NDVI, as you can see. So if you want to export it, you need to add export code to this one. So I'm going to show you the results. So after getting all your code, you set your study area, you add your Moody's data, and then you add your year, then you are good to go. So the next thing we are going to do is we are going to click on run, as you can see here. Okay, so this is our results for NDVI, and then this is our NDVI time series analysis, that is for 2000 to 2023. So let me quickly change this one. So on this side we have our visualization parameter where we can change our custom to, let's say, 98. We can stretch it to 98, and then here we can change the color too. So if you want to change the color of your map, you can do so here, as you can see. Alright, so here, as you can see, our NDVI value ranges from -0.02 to +0.4. so where we have low NDVI, you can see where water body is, we have low NDVI, and then where vegetation is, we have higher NDVI. So you can see all these places are water bodies. Let me zoom in so that you can see it well. Alright, so all these places has a lower NDVI since the places were waterlogged area, and then where vegetation is, we can get here we have a vegetation there, that's where we have our higher NDVI, and then where water body is, that's where we have our low NDVI. And then we can change the colors here. So if you want to add any color or if you want to change the color, you just have to click on it and then you click OK. So let's view our time series and see how NDVI has been changed. Okay, so this is our NDVI time series. We have NDVI time series 2024. So how NDVI has been ranging from 2024. So as you can see it here, we have from 2000, 2024, 2026, 2028. So you can see we have 2 years interval here to 2022, and then the last one is 2023. So in 2000, so 2000 will be here. As you can see, we have 2000 February there, that we have NDVI of 0.28, and then it ranges to 0.4, and then as here we have NDVI of 0.4 again, 0.4 again, then we have NDVI of 0.5, and then we have NDVI of 0.2. so it ranges from -0 to 0.6, as you can see. So when you put your cursor on it, you can see how the NDVI values are changing within the years. So as you can see, when you put the cursor there, you can see we have January 25th, and then we have our NDVI value at the bottom. So this is how you calculate for your time series NDVI analysis. So if you want to download this one, you can use your CSV, or if you want to download it in image form, you can just download your PNG here, and then you continue with your analysis. So thank you very much for your attention, and please don't forget to subscribe, like, and share. Thank you.